For 2,000 years after the Greeks, we thought of electricity and magnetism as different phenomena. It wasn't until the 19th century that we discovered that they are, in fact, different manifestations of the same thing. Now, not a lot of people know this, but this silver box inside a traffic island in South London is in fact a monument to the man who set us on the road to that profound discovery, Michael Faraday. Inside here is an electrical substation that powers the Elephant and Castle tube station across the road. Now, the original idea was for this to be made of glass, so you could see the electrical transformers inside. And I think that would have been an even more fitting tribute to the genius that was Michael Faraday, because it's really true to say he was the founding father of the modern electrical world. Well, this is a more obvious monument to Michael Faraday outside the Institution of Engineering and Technology. And in here, they have some of Faraday's original notebooks. In this notebook, in Faraday's own elegant, if rather illegible handwriting, is a reference to his most famous discovery. It's here in the title: Convert Magnetism into Electricity. What Faraday had found is if you take a coil of wire and you move a magnet around inside it, you generate electricity. And it's machines like this that lie at the heart of every power station in the world. Faraday had shown that electricity and magnetism are intimately connected, but they weren't yet unified together into a single mathematical framework. It took a very different kind of physicist, James Clerk Maxwell, to see the true connection, and with it produce a revolution in our understanding of the universe that Einstein later described as the most profound and the most fruitful that physics has experienced since the time of Newton. This is the lecture theatre where Maxwell stood and taught electricity and magnetism to his students. I want to show you something about the beauty and predictive power of mathematics in the hands of Maxwell. These are almost Maxwell's equations. They predict everything that was measured by Faraday and his colleagues about electricity and magnetism throughout the 19th century. This, for example, is Faraday's law of electromagnetic induction. But Maxwell noticed that these equations are not mathematically consistent. He was forced to add an extra term, which is called Maxwell's displacement current. With this extra term, these equations can be recast into this form. These equations are equations for electromagnetic waves, waves of light. So, in one piece of genius, Maxwell had unified the forces of electricity and magnetism and made a profound connection between electromagnetism and light itself.
Maxwell's unification of electricity and magnetism is regarded as a great milestone in physics because it was the first time when two disparate pieces of physics, electricity and magnetism, both thought of as separate physical processes, were brought together under a single theory which incorporated the two together, and that's a very important thing in physics, to try and explain as much as you can as simply as possible.